Hello and welcome back to lesson number 2 of data and statistics. Now we're going to be talking about something called data distribution. This is when we're going to get a little bit more, I don't know if you call it exciting necessarily, but a little different from what you've seen in the past. So let's get right into it. Distribution is just a way of presenting data. This could be like charts or graphs or however you're displaying your data. You're distributing it so that people can read it and understand what's going on. And you always want to make sure that you're choosing an appropriate way of doing this. Sometimes you see crazy things like pictograms, and they show you, like, I don't know, a person represents 10 million or something, and it can sometimes be misleading depending on how you set them up. So I'm going to show you guys some pretty straightforward ones that usually work and are very quick and easy for people to see how they, the true scales of things. We're going to look at a line plot distribution first. Okay, before we do though, here's some things of how we would describe distributions. You have what's called uniform distribution, where the data looks flat or straight across, and I have examples of this right here. Right, maybe our data is all just lining up straight here. Right, nothing really happening. Next one you would have would be called a normal distribution, which is mounted in the middle with tails at both ends. It's also called a bell curve. When you hear me talk about, I'm going to scale our test and everything else, it's based off of this idea of a bell curve, because there's a little bit right here that not too many people got. Right, that little bit that would have a perfect score, barely anybody got it. Most of you scored in here, so I'm going to give you those few extra points to kind of help you guys along. The idea of the bell curve and me giving you that scale. And then you have finally skewed distribution, which is mounted at one end with a long tail on the other side. So you would see a little bit of information showing up here, and then boom, here's where most of the stuff shows up. Same idea over here. This is called skewed left when you have a tail on the left, and skewed right when you have a tail on the right. I generally get those confused all the time, and very possibly could have gotten that confused on here, but I checked it before I put it, so you can trust that it's correct. But if you don't trust it, check Google. Google will tell you. So, with these problems, if you want to pause the video to copy down these tables real quick, you'll notice that it tells you to make a line plot and determine the distribution type. And I'm giving you two different pieces of data, and you're going to do two different little things here. And you'll notice that I already have these set up, but I have them already pre-counted because I know how many I need. You might not know that necessarily when you do these on your own. Anyways, so we've got to look at the smallest number here. On the top layer, it looks like the 22 is the smallest one that we have, and it looks like we're going to go up by 1. Oops, and it looks like 28 is as far as we need to go. And I know that we're doing the trunk circumference in inches, and all I have to do is just put little X's wherever we see a number pop up. So 28, 26, 22, 25, 28 again, 27, 25, 27 again, 27 again, 26, 23, and 27 again. Alright, so if we look at this particular set of data, it's going like this. So most of our data is over here on the right side. We have a tail on the left. So we would say this is skewed left. All right. Pounds of fruit produced from that particular tree. Again, we're just going to label this here first. The lowest number that we have would be 12, it looks like. So 14, 15, 16, 12, 15, 14, 15, 13, 17, it's 13, 16, 14. This is a perfect on both sides. That looks like a mound. To me, I would call this a normal or bell curve distribution. Alright, so here's one for you to try. These are actually pretty nice, easy, kind of fun, to be honest with you, just kind of making little X's. Pause the video and resume when you're ready to check these. Alright, so I throw a little bit of a curveball at you for this bottom one, but let's just start with the top one. Lowest number that we have in the top here looks like 88. So we got one at 89, 91, 88, 91, 90, 92, 91, 90, 90 again, 93, 90, 89. That looks pretty balanced. I would call this normal or bell. And then the number of hours studying. Now the little curveball that I threw at you here, the lowest number that we have is 1. But if you noticed, there are decimals, so you needed 1.5, 2.5, and 3. So let's see. 1.5, 2.5, 1, 2 2s, 3, 2.5, again, 2 3s, 2.5, and 1.5. I mean, you could probably call this skewed left. I would. Most of our data happens to be over here. Maybe if they were a little bit less over here, it might be more clear. Pretty easy so far, right? So that's your stem and whisk. I'm sorry. That's your what is that, line plot. I probably could have done stem and whiskers. I didn't even think about that. We're going to do stem and leaf, rather. Wow, I'm mixing stuff up. We're going to do box and whisker next. These are also kind of easy to do, quick visuals of where most of the data exists. Works with the median, averages, and breaks the data into quartiles. So if we're doing a box and whisker plot, when we do these, we have to put these in order first, and then we have to think about these whole quartiles. And these are nice because what you just saw before kind of worked more with like the mean average, where this will help us more with the median average because it's breaking it into the middle and quartiles. So first thing we've got to do is we've got to order this in the correct order. I'm going to do that above right here. And again, there's a lot of numbers here, so if you want to fast forward until you see all of them written here, you can jump right ahead. Or if you want to do that with me, whatever. Doesn't matter. So the lowest number I have here looks to be like 31. 32. 32. 33. 34. 1, 2 35s. 36. 37. 3/38. 39. And we got 2/41s. All right. So the very first thing we had to do is put these into order. And because we're talking about median, we know that they have to be in order. So we're going to break this up into quartiles. And I'm going to real quick just make sure that I'm saying the right thing for you guys when I label these quartiles. All right. Just make sure. All right, yeah. So we have it in order, and we're going to find first the median, which is going to be, we'll label that after, but we're going to find the median of all this data. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers here. Ooh, is there really? 17 because I missed this 41. Good thing I counted again. So there's 17. 17 divided by 2 would be 8.5. So we want to round up to 9. So if I count 9 this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is our middlemost number, is 36. Then we're going to break it up into the rest of the quartiles. What that means is I'm going to find the median from our median to our ends. So if I ignore this side, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 9 divided by 2 is 4.5, round up, so 5 this way. 1, 2, 3, 4, 5. Here, that is another important number. And again, I have 9 on this side, divided by 2, 4.5, plus round up is 5. So from here, 1, 2, 3, 4, 5. Here's our other important number. Okay? Now I know that these are kind of in not the greatest spot for notes, but right here, this is called your first quartile. This right here, the middle, the median, this is called your second quartile. And this would be your third quartile. And these are just called least and greatest. But what these basically do is it tells you everybody is on this spectrum from least to greatest. And a quarter of the numbers happen to fall from 0 to the first quartile. Half of the numbers would fall under the second quartile. 3/4 would fall under the third quartile. So it's just telling you how many people would fall into those categories. So it's another kind of nice way of looking at and displaying the data. So we need to label this 31, 32, 33, 34, 35, 36, 37, 8, 40, 41. All right, so it goes from our least to our greatest. And when you do stem and leaf plot, I'm sorry, I keep on saying the wrong thing. I'm going to show you guys how to do that at the end of this video. Box and whisker. When you're doing a box and whisker, you always put a line, I guess, for your whiskers at your ends. Right, so we have one at 33 and we have one at 34. Then we're also going to be putting the same kind of lines at these quartile marks. So at 34, I'm also going to have a line, 36, and then 38. And then all we have to do is connect the middle 3 lines with a box. So that's the box, and then you draw the middle lines here for the whiskers. Now, sometimes people like to shade in one of these. Anyways, what this is doing is it's showing you visually where a lot of the data exists. The longer the whisker shows you that you have extreme far numbers, which maybe could be like something that could be skewing it or offsetting it. Could be a biased result, right? So these are kind of nice to look at, the medians and the quartiles. they're easy to read too, because you could say, you know, like, I don't know, 3/4 of the numbers happen to be less than 38, and you can see that real quick. You know that out of these numbers, there's 10 numbers here, 1/4 of them were the first 4. So that's, you know, you can find some different information about these. So you have one right here. This is the last problem that you have to do. I'm going to give you a bonus bit of material after this, but here's the last one. Pause the video and check when you're ready to see the result. All right. So what you needed to do was put these into order. The smallest number I believe here would be 10. So 10 is my first number. I have a second one. I have a third. 1, 2, 3, 4, 11s in a row. Oops. 1, 2 12s. 13. Did I miss a 12? I did. I missed a 12. All right. Good thing I didn't go too far. 14. 15. 2 15s. 16. 18. 19. 19. Alright, so I always like to double count just to make sure that I didn't miss any. It really can't hurt to do that. We have 17, so again, we need to find the middle number first. That would be the median, and again, 17 divided by 2 is 8.5, round up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. By the way, it isn't like the coolest of tricks or anything, but if you counted 9 this way, you end up at the same spot. So I'm going to finish labeling this real quick. Oops, we don't have. Gotta extend this just a little bit. Uh-oh. I think this pen finally died. Oh, here it is. Alright. 19. So, we found our median. That's the second quartile. Our end is 10. Our other end is way over here at 19. Oops. That's okay, we'll fill in the other stuff in a second. So let's see. There's 9 here. Half of 9 is 4, round up. So 1, 2, 3, 4, 5. Here's our first quartile is here at 11. And then let's see, 1, 2, 3, 4, 5 right here is our third quartile at 15. And there you go, there's your box and whisker. So it's kind of interesting again to see that you have a bunch of information happening between 10 and 11. That means that there's a lot of 10s and 11s just seeing this, right? Versus in between here, out of the 16, 17 numbers that we have, maybe there's one of each. Maybe there's a couple of one and some of them missing. So that's box and whisker plot. Okay, so that is the end of the lesson as far as your notes go. However, I keep on talking about stem and whisker. No, I mix them together. I keep on talking about stem and leaf. We just did box and whisker. And as an added bonus, I'm going to show you real quick how to do stem and leaf plots as well. I'm totally making this up right now. And again, you don't need to see this. If you want to end the video now, that's fine, but I'm going to just kind of quickly make up a couple of numbers here. Maybe not. Yeah, we'll go with the one that I was just doing. Sorry. All right. All right. So I just kind of made up a whole bunch of random numbers here for our stem and leaf. And this is something that kind of helps us out with mode. They're not the most useful things ever, but it's kind of a quicker way of not having to write stuff out as much. And it kind of helps counting in that type of stuff too. Anyways, so what we're going to do here is we're going to have what's called the stem, which is going to be our first number, the numbers that there's only the fewest of. As far as placement goes, like this is our tens place, there's the fewest numbers of changement, of movement in our range, right? We have 1, we have no 2s, we have 3s, 4s, 5s, but there's nothing after that. So we're going to label these as 1, 2, 3, 4, 5. These are your stems. What you're going to do from here is, if anything that starts with a 1, you're going to write from least to greatest the leaf that comes after it. What I mean by that is, I have a 10 here, a tens place, a 1, and I have a 4. I don't have anything else after that though, so I'm just going to put a 4 here. For the 2s, we don't have any, so we're not going to put anything. Not a 0, just nothing. The 3s, right? By the way, I'm going to get rid of that. My 3s, I have a 39, and I have a 35, and a 32. So if I put these in order of just the 1's place, I would have a 2, a 5, and a 9. 4s. Let's see, I have a 1. Actually, I'm sorry, I did those in the wrong spot, didn't I? Sorry, we said that one was blank. The 4s, right? We have a 1, a 2, a 3, and I noticed that I missed a 7 here, so I'm going to change that to a 7, and a 9 for the 4s. Okay, so yeah, I do sometimes miss some numbers. I'm sorry about that, guys. Like I just missed this 8 here as well. But if you're just careful and you go through, make sure, you'll notice that you miss stuff. 51 happens first, then 3. Oh, 2, I guess, happens before 3. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so I have all of them down. So now you can see these are our stems, there are our leaves. Now you can start to see a lot more other stuff, kind of work with mode a little bit if you want, like what stem shows up the most for, right? The 40s show up the most, so now you can kind of look at maybe the averages. If that shows up the most, which one happens to have the most numbers show up, right? That's most likely. Or maybe you have the most reoccurring in a different grouping, but you can see that pretty quickly using these stem and leaf plots. You can also work with median at this point, right? This is 14, so you can start counting backwards and doing that whole trick if you wanted to find the median. But that's the stem and leaf. Now, you only needed to know the line plot and the box and whisker, but because I kept on saying stem and leaf, I figured throwing this a little bit of bonus for you. So if you stuck with it that long, good for you. See you on the next video. Bye.